Welcome back to TEC Tube. I am Ryan Hoger, and today we are standing here at one of the rooftops in the lab. This is obviously an eco blue rooftop, because you can see it has the blue fan, but that is not our interest today. Today we're going to talk about Humidi-MiZer. Humidi-MiZer has been around with Carrier and Bryant for, I don't even know, decades. We used to call it Moisture-MiZer back in the day, and it's got modified a little bit. Now it's Humidi-MiZer. This has been traditionally available on all of our larger tonnage rooftops, but nowadays it's available all the way down to 3 tons, as small as that. When you open up the door on this unit and you look inside here, you're going to see that there's a couple valves you're not used to seeing, and you'll be like, what the heck is that? And then when you look a little bit closer in here, you're going to notice that there's actually 2 evaporator coils in here. So we're going to explain to you what those 2 coils' jobs in life are. The one further back, that one actually is the real evaporator coil, and the second coil that's closer to us right now on the discharge side of it, that's going to be the extra Humidi-MiZer coil that we're going to talk about. Now what you can see in here, if I move the fan a little bit, take the shroud off, you might be able to take a closer look in here. But we have these 2 solenoid style fast acting type valves. And down on the left hand side, if you can see a little bit, you'll see that the little U-bend's on the first coil over here. So there's a little bit less space there. So if you're installing accessories like UV bulbs and stuff like that, you got a little bit less to work with, but I think you're gonna really like the benefits of the Humidi-MiZer. So let's take a look at how that works. So this Humidi-MiZer option has 3 primary modes of operation. First off is a regular temperature-based mode of operation, just like every air conditioning system has. So we get a call for cooling, we're gonna turn on the system, we're gonna flow refrigerant through the condenser and evaporator just like normal. We'll walk through that and provide you normal 55-degree supply air. Then there's a dehumidification option. So temperature is totally satisfied. You asked us for whatever, 74 degrees. We gave you 74 degrees in the room, everything's good, but the humidity is high. So the thermostat or humidistat calls for dehumidification, in which case we're gonna be able to cool and then reheat back to a comfortable temperature for discharge. So 70, 75 degrees. I'll walk through the piping of that. And then we have a subcooling mode, which is fairly unique. That's kind of a Carrier specific thing. Bryant does it as well, obviously. And we have a call for temperature and a call for dehumidification. So let's look at the piping of these guys. So let me get my little arrow out here. So this is our normal mode. Right, refrigerant leaves the compressor, flows through the condenser. This extra valve is shut off. We're not bypassing the condenser. So all the refrigerant goes through the condenser, it rejects its heat to the outdoors, it flows over to the TXV. Because this valve is open, the refrigerant flows towards the TXV. TXV changes the state there. We get the cool refrigerant, goes to the evaporator, makes you your cold air, repeats the cycle, normal refrigeration cycle. If you need help with that, check out one of our previous videos on the refrigeration cycle in general. So that's the normal mode. When I have a hot gas reheat mode, that means I have a call for dehumidification, but I do not have a call for temperature removal, for temperature reduction. So you asked for 74, it is 74, but you also wanted to have it dehumidify, we need to do that. So the refrigerant leaves the compressor. Now this valve over here is open, so the refrigerant bypasses the condenser. So we do not reject heat to the outdoors. And instead it comes over here, and this extra coil that we showed you earlier on in the video, that Humidi-MiZer coil, that guy basically becomes your condenser coil. So instead of rejecting heat to the outside, we're rejecting heat on the inside airstream. And then we flow through that coil over to your TXV, we change the state, and we go through the regular evaporator like normal. On the air side of the equation, air comes in, gets cooled and dehumidified with the evaporator, but because we didn't really want to cool it, we then reheat it with that Humidi-MiZer. So it goes to the evaporator, the indoor air, and then it goes through the condenser coil essentially. That's the hot gas reheat mode. And a lot of manufacturers do that. That allows you to get a medium temperature, 70, 75, 77 degree discharge air into the space while still pulling a lot of moisture out of the evaporator. The unique thing is the subcooling mode. So now the refrigerant leaves the compressor, it does flow through the condenser, it does reject heat outside, but then it goes to the Humidi-MiZer coil where it can further cool the indoor air, and then through the evaporator where it cools it again. So now I have like 2 cooling coils essentially. So on the indoor air side, it goes to the evaporator, which is seeing the coldest refrigerant, then it goes to the Humidi-MiZer, which is also seeing fairly cold refrigerant, and then into the space. So we're able to kind of get really cold and dehumidify with the evaporator, and then only slightly warm it up. Whereas previously with the hot gas reheat, I had pretty warm refrigerant here on the Humidi-MiZer coil. Now on this mode, subcooling mode, because I've rejected most of the heat outside, I only have what I'm gonna call mildly warm refrigerant on the Humidi-MiZer coil. So I'm not gonna be tempering it up to neutral 70, 75. It's gonna be more in that 60, 62, 65 degree discharge air. So we get 3 modes of operation there. Regular cooling, dehumidification, and cooling plus dehumidification mode. Kind of applications you would use this on are ones that have a lot of need for latent removal. Fitness centers, gymnasiums, stuff like that are excellent candidates. So hopefully that helps you understand how this system works, and when you see one in the field, you know exactly what you're looking at.